Hello, friends. Listen to me. When we observe the stars in the sky, they are twinkling, twinkling. Why the stars are twinkling? Why those stars are twinkling? And also, when we observe the stars, they are appear. Those stars are appear in different colors. They appear in different colors. Different colors. Stars are appear in different colors. Why? They appear in different colors. Think about those two. And another one, bicycle. What is the principle behind the balancing of the bicycle? What is the principle behind the balancing of the bicycle? Principle behind the balancing of the bicycle. What is the principle behind the balancing of the motorbike? Do you know about the helicopter also? Helicopter. When you observe the helicopter, it is having two propellers. Why it is having two propellers? Why the helicopter is having the two propellers? What is the principle behind by using the two propellers in case of the helicopter? Aeroplane. If you consider the aeroplane, what is the principle behind the flying of the aeroplane? We know the flying of the bird, principle behind the flying of the bird in our ninth standard. It is Newton's third law of motion. Now, what is the principle behind the flying of that aeroplane? This aeroplane. What is the principle behind the taking of the aeroplane from the runway? From the runway. Okay, again, another one. About 30% of deaths in the world, about 30% of deaths in the world are because of heart attacks. About 30% of deaths in the world are because of heart attack. What is the principle involved in this heart attack? What is the principle behind the heart attack? And next, now you consider a raindrop. Raindrop. If you consider a bullet which is emerges out from the barrel of the gun, what is the speed of that bullet? Average speed. Think about that average speed. Okay, it is about 200 to 350 meters per second. About 150 otherwise. 150 to 300 meter per second. 150 meters per second to 300 meters per second. That is average speed of the bullet. Gun to gun, it will change. Now, you can assume the raindrop. From what height that raindrop is falls? That raindrop falls from what height? It is about 15 kilometers. That's my assumption. It is about 15 kilometers. When we observe the clouds, What is the height of the cloud above the ground? It is about 15 kilometers. Just you can assume it falls from a cloud. That raindrop falls from the cloud. That raindrop height is 15 kilometers. The height of the cloud is 15 kilometers and the raindrop is falls from that cloud. Just before it hit on our head, what is the speed of the raindrop? Just before it hit on our head, what is the speed of the raindrop? Tell me. What is the speed of the raindrop? How you will calculate the speed of the raindrop? Okay, it is falls from this height. Just it is allowed to fall. That means I am assuming that its initial velocity is equal to 0. Its initial velocity is 0. Okay, it is falling under the gravity. It is falling under the gravity. Remember this. And therefore, its acceleration A is equal to g meter per second square. G is acceleration due to gravity. Just before it hit the ground or just before it hit on our head, to calculate the velocity, you are using the formula v square minus v naught square is equal to 2as. I think you know about this formula, this familiar formula in your 9th standard. 9th standard. Not only in 10th, it is in 9th standard. Equation of motion. And here A indicates uniform acceleration. Okay. V square. We want to calculate minus 0 square is equal to 2 into A nothing but 10, 9.8 meter per second square. Approximately I want to consider it as 10 meter per second square. Yes, 15 kilometers, nothing but 15,000 meters. 1 kilometer, nothing but 1000 meters. 15,000 meters. Now you can calculate this. B is equal to square root of 2 into 15, root 30, 0, 4 zeros, root 1000, root 1000, nothing but 30, root 3 into root 10 into 10 square. Okay, I think it is 10,000, I am sorry, 10,000, 4 zeros, 2 ones, 3. Root 3 into 10,000, nothing but here root 3 into 100. What is the value of root 3? 1.732 into 100. Approximately 173.2 meter per second. Root 3, 1.732 into 100. Now, if the bullet hit our head, what happens? Think about that. Now, if the raindrop hit our head, what happens? Does it happen there? No. What happened? Why? The raindrop is hit our head with this much of velocity. If it hit this much of velocity, how we feel? The drop is penetrating to our head, but it is not doing so. Why? What is the phenomena? Is it moving with that much of velocity? No, it is not moving with that much of velocity. It is not moving with this much of velocity just before it hit our head. Why? Its velocity decreases. Actually, the raindrop hit our head with less velocity. Why? It is moving down, coming down with less velocity. What is the principle behind it? What is the principle behind it? What is the principle behind in it? Okay. In the same manner, while we catch the ball, we pull our hands our hands in the backward direction. We pull our hands in this manner. Why? You pull your hands in the backward direction. When you catch it abruptly, what happens to you? You may get hurt. You may get injured. That hands may get injured. Why? Why? When we pull our hands in the backward direction, we are not feel anything. What is the principle behind it? Okay, it is familiar to you. In our ninth standard, it is an important example, I think. Okay, what is the principle behind it? Think about that also. Okay, fruits, to transport the fruits. In order to transport the fruits, they are wrapped in the paper. You can observe papayas, bananas. In order to transport from one state to the another state, from one place to the another place, they are wrapped in papers. In the similar manner, electronic goods, in order to transport that electronic goods also, they wrapped in the paper. Why? What is the principle behind it? Tell me, what is the... Okay, another common example. You know about the lift or escalator. Lift or escalator. Lift. While the lift is moving in the upward direction, that is from ground floor to 5th floor or 10th floor or 20th floor, we feel our weight is increases. And the same manner, when the lift is suddenly moving in the downward direction from 20th floor to the ground floor, while it is moving in the downward direction, we feel our weight is decreases. The best thing, it is the giant wheel. While you are moving in the giant wheel, while the giant wheel is moving in the upward direction, we feel our weight is increases. While it is moving in the downward direction, how you will feel? What is your feeling? Oh, our weight is decreases. We are not feel comfortably. We are not feel comfortably. Why it is doing so? Why it is doing so? Okay, we are walking on the ground with our foot. What is the principle behind the walking? What is the principle behind the walking? Already we know that it is very easy to walk on hard floor than the tough sand floor. It is very easy to walk on cement floor when compared to the sand floor. What is the principle behind that? Okay. Do you know an useful evil in our life? Evil. An useful evil in our life. What is the useful evil in our life? Without this, it is not transport to the motion from one part of the engine to the another part. Without that, it is not possible to hold an object with your hand. But because of this, large amount of energy may be wasted. That's why I want to call it is an evil. What is that useful evil in our life? Okay, think about these questions. Now I will introduce myself here. I will introduce myself. My name is Anil Kumar. I want to discuss the physics subject here. All these principles are belongs to physics. These are the natural things. Every day we are observing these type of natural things. We will discuss the principles behind these natural things in +1 course or in intermediate course or in first year intermediate course. Very, very interesting principles. I think these are very interesting principles. Remember that. That means which subject it is? Physics. I'm going to discuss about this subject, physics. In this, I want to discuss a concept, motion in a straight line. I want to discuss a concept, it is motion in a straight line. In order to understand the basic principles which are involved in daily life, first we want to know about this concept, that is motion in a straight line. Motion in a straight line. Okay. Now, what is the state of this board? What is the state of this board? You are saying that it is rest. Okay. When you observe me, I am moving. What is the state of me? What is the state of this person? What is the state of myself? With respect to you, I am is in motion. Okay, here, what is the, okay, you can consider, I am sorry, a familiar example, another familiar example. A bus. Inside the bus, two passengers are there. And the bus is moving in the forward direction. With constant speed, it is moving in the forward direction. What is the state of first person with respect to the second person? State of first person. State of first person with respect to second person. State of first person with respect to second person. Rest. We can say that he is at rest with respect to him. State of second person with respect to the first person. Rest. But with respect to another person or trees, whatever it may be, with respect to the another person who is standing on the ground, a person B, I'm assuming a person B, who is standing on the ground. With respect to him, what is the state of the first person and what is the state of the second person? They are in motion. You can say that they are in motion. What is about the trees which are present on the ground with respect to the first person? Okay, before going to that, with respect to the tree, what is the state of this person? Rest. What is the state of this person? Rest. With respect to these two persons, that is with respect to the passengers which are inside the bus, what is the state of B? With respect to person 1, state of person B. is, tell me, motion. He is in motion. The person B is in motion. What is about the trees? Tree is also in motion. It is also in motion. It is the common thing. When you are in the bus, when you observe the things which are outside the bus, they appears they are moving in the backward direction. That means you feel that those objects are in motion. With respect to the bus, what is the state of the person one and state of the second person? Both are at rest. That is, with respect to the person B, he is in motion. He exhibits anyone. He exhibits both the states simultaneously. The person 1 or person 2 exhibits both states simultaneously. Both states simultaneously. With respect to the bus, he is at rest. But with respect to this person or with respect to the tree, he is in motion. Now, with respect to the tree, he is at rest. But with respect to the person one, he is in motion. Earlier, I told that board is at rest. But with respect to me, this board is in motion. Is it true? That is, here, what is meant by the rest and what is meant by the motion? Before going to that, again, I will explain one example. Another example. What is the state of this board? With respect to the given room, rest. You are saying that it is at rest. What is the state of this room with respect to this house, with respect to a given house? It is at rest position. With respect to the earth, what is the state of the board and what is the state of the room? With respect to the earth, what is the state of the board and what is the state of the room? They are also be at rest. With respect to us, what is the state of the earth? No, it does not rotate. With respect to us, it is at the rest position. Is it appears? Does it rotates with respect to you? No. Actually, earth rotates about its own axis. And also it revolves around the sun. But with respect to us, it appears that at rest position. Okay. With respect to us, what is the state of the earth? State of the earth. Yes, it is rest. With respect to moon, what is the state of the earth? It is in motion. It is in motion. Is it true? Or with respect to the sun? With respect to the sun, what is the state of the earth? It is in motion. Now, with respect to the earth, we are at rest. Is it true? But with respect to the moon, we are in motion. That means this board also exhibits two types of the states simultaneously. With respect to you, it appears that this board appears that it is at rest position. But with respect to the person who is standing on the moon, he said that it is in motion because it is moving along with the earth. Therefore, this board also exhibits two states simultaneously. Earth also exhibits two states simultaneously. What are those two states? Rest and motion. Rest and motion. rest and motion. What is meant by the rest? Now you tell me the definition for the rest by using these examples. You can assume the board is a particle. Okay, now you tell me the definition for this. Yes, it is. The position of the particle does not changes with respect to the surroundings or with respect to the time. The position of the particle does not changes. The position of the particle does not changes with respect to the surroundings. With respect to the surroundings, we are called it as rest and motion. What is meant by the motion? Yes, the position of the particle changes with respect to the surroundings. The same thing. With respect to us, the boat is at rest position. That's why its position does not changes with respect to the surroundings. That's why we are called this board is at rest position. But with respect to the moon or with respect to the sun, what is about the state of the board? Changes. That's why motion means the position of the particle. The position of the particle changes with respect to surroundings. The position of the particle changes with respect to the surroundings, we are called as motion. Does these two are absolute terms? That means by its own it is having the definition. By its own the motion is having the definition. No. With respect to the another particle, it is possible to say the state of that particle, another particle. In order to say the state of this blackboard, it will require another reference particle. That is, with respect to the surroundings, we will say the state of this board. That's why this rest and motion are relative terms. Motion are relative terms. Rest and motion are relative. They are not absolute terms. Rest and motion are relative. Remember that. Here, instead of the board, I am saying a particle. Does the board is a particle? With respect to your eye, is that board is a particle? Is this pen is the particle? No. Your answer is no. No. With respect to your house or with respect to this blackboard or with respect to the room, you can consider an ant or housefly or a mosquito. How these are appears? Very small particles. There appears very small particles. If you consider one sand particle, in the name we are called it as a particle. It is also a particle with respect to this entire room or board. With respect to this your entire house, it appears like a small particle. Ant appears like a particle. Fly appears like a particle. Okay, with respect to this city, your city, I think it is Hyderabad. With respect to the Hyderabad, what is about this board? When you observed it from Google Maps, how it is appears to you? Small thing. Your house. When you observe your house, with respect to this Hyderabad, how it is appears to you? Very small thing. That's why, with respect to this huge city, huge area, we can say that this board is a particle. Do you understand about this? With respect to this entire earth, what is about a bus on the street or a bicycle on the street? Yes, it is also a particle. It is also a particle. Now you can consider the train. Is it is a particle or an object? Train is a particle or an object? Yes, with respect to us, when you are on the platform, when we are on the platform, we can say that train is a big object. Train is a big object. But if you consider it in between, it is in between the two stations. Those two stations are, one is Hyderabad, and another one is Hazrat Nizamuddin. What is the distance between these two stations? Okay, nearly about 1500 kilometers, I think. With respect to that distance, what is the train shape? It is a particle. Does you are saying it is an object with respect to this total distance? No, it is also appears like a particle. But if you are on the platform, it appears like an object. It appears like an object. Earth. What is about the earth? With respect to us, it is a very big object. With respect to us, it is a very big object. With respect to the entire universe, what is about this earth? When you are observe the stars, how? What is the size of that star? Yes, it appears like a small particle to us. That is, with respect to this entire universe, it is also be considered as a particle. Now you understand where we are considered an object as the object and it is as a particle. With respect to the surroundings, with respect to its surrounding object, we can decide whether it is an object or a particle. Remember that. Okay, in these two definitions, I am saying that a particle, that is, the position of the particle does not changes with respect to the surroundings. The position of the particle changes with respect to the surroundings. Instead of the particle, you can say the object also. Okay, do you understand the difference between rest and motion? Does these two are absolute? No. In order to define both of them, something should be taken as the reference one. That's why these two are relative terms. Remember that. Now, here I am asking one question. What is meant by the physical quantity? What is meant by the physical quantity? Anything is taken as the physical quantity? No. The quantity which is measurable in nature. The quantity which is measurable in nature is called physical quantity. Called a physical quantity. The quantity which is measurable in nature, we are called as a physical quantity. Now, okay, is time physical quantity or not? Yes, because it is measurable in seconds or in milliseconds or in hours or in minutes. Length, it is also measurable in meters, in centimeters, in millimeters or in kilometers, like that. It is also measurable. Kilogram, sorry, mass, it is also physical quantity. Its unit is kilogram, like that, grams, pounds, in that manner. Work, yes, it is also a physical quantity because it is also measurable in joules. 20 joules of work, 30 joules of work. Heat, 20 joules of heat, 10 joules of heat. That is the quantity which is measurable in nature, we are called as physical quantity. Okay, again, these physical quantities are divided into two types. One is fundamental physical quantity, fundamental physical quantities, and another one derived physical quantities. Derived physical quantities. In system international, that is international system of units. In international system of units, we are saying that SI. In international system of units, there are 7 fundamental physical quantities. 7 fundamental physical quantities. What are those 7 fundamental quantities? You know about them? You think you know about those 7 fundamental physical quantities? They are familiar to us. Now, what about the derived physical quantities? The quantities which are derived from the fundamental physical quantities are called the derived physical quantities. The quantities which are fundamental in nature for our convenience to develop the physics and for our convenience in System International, scientists developed 7 fundamental physical quantities. 7 fundamental physical quantities. Okay, they are length, mass, time, electric current, thermodynamic temperature, quantity of matter, luminous intensity. Check this. 1, 2, 3, 4, 5, 6, 7. Does the masses depends upon length? For a given body, mass is 12 kgs, length is 2 meters, like that. Is the time depends upon mass? Nothing. No. Electric current is depends upon mass? No. One physical quantity does not depends upon other physical quantities. This physical quantity does not depends upon the remaining 6. This physical quantity does not depends upon remaining 6. That is, these are fundamental in nature. That's why we are called, they are the fundamental physical quantities. Derived physical quantities, the quantities which are derived from the fundamental physical quantities. The quantities which are derived from the fundamental physical quantities. Which are derived from fundamental quantities. Fundamental physical quantities are fundamental quantities. We are called as derived physical quantities. Now you tell me, what is the derived physical quantity? Example, I am asking about the example. Yes. It is distance, displacement. These two are derived from the fundamental physical quantity length, and you can consider speed. What is meant by the speed? Simple thing. You give me the simple definition. Speed nothing but distance divided by time. Okay, it is not the correct definition. We will go through that correct definitions little later. Simply we can say that it is distance divided by time. That means speed is derived from which physical quantities? Distance and time. Distance is derived from which physical quantity? Length. Therefore, speed is a derived physical quantity. Similarly, velocity, displacement by time, acceleration, velocity divided by time, force, mass into acceleration. Now you tell me, all these are derived from these fundamental physical quantities or not? Yes. That is, derived physical quantities nothing but the quantities which are derived from fundamental physical quantities. We are called as, they are the derived physical quantities. Now, again, what is meant by the physical quantity? Yes, it is the quantities which are measurable in nature. The quantities which are measurable in nature, we are called as physical quantities. Again, for our convenience, the physical quantities are again divided into two types. They are scalar, another one is vector. One is scalar and another one is vector. I think these two are also familiar to you in our lower standard, that is either in 10th or in 9th. Okay, I'm asking about the definitions for both of them. What is meant by the scalar and what is meant by the vector? Yes, tell me. Scalar nothing but a physical quantity which is having only magnitude. The physical quantity which is having only magnitude but not direction. That type of the physical quantity we are called as scalar. A physical quantity which is having only magnitude, we are called as a scalar quantity. Now, what is meant by the vector? Okay, recall the definition for the vector. Yes, it is a physical quantity having magnitude, both magnitude and direction. Both magnitude and direction. Is it correct or not? A physical quantity having both magnitude and direction, it is a vector quantity. A physical quantity which is having only magnitude, we are called it as a scalar quantity. Okay, now you tell me the example for scalar. Any quantity which is not having magnitude, nothing but length. We are not considering the direction in order to measure the length of the object. Time, we are not mention any direction to calculate the time. Mass. Similarly, path length or length of the path. nothing but distance. Speed, we will discuss about these things later, why they are not having the directions. Okay, path length, speed, work, power, these are not, we are not mentioned the direction for these physical quantities, for these type of physical quantities. These are having only magnitude, that means value only, measured value they are having. While we are measuring them, we are not considering any direction. Okay, that's why these we are called as scalars. What is meant by the vectors? Physical quantities having both magnitude and direction. I think this definition is wrong. Yes, I think it is wrong. The definition is wrong. Okay, we learn the definition in 9th standard or also in 10th standard in the similar manner, but I think it is wrong. Why? You know about the electric current? Yes. Does it is having both magnitude and direction or not? In case of the circuit diagrams, we will mention the direction of the electric current also. That means electric current is having, listen carefully this, electric current having both magnitude and direction. It is having both magnitude and direction. In the circuit diagrams, we provide the direction to this electric current also. But it is not a vector quantity. It is not a vector quantity. Already we learned that electric current is a scalar quantity. It is not a vector. Even though it is having both magnitude and direction, it is not a vector. No. Velocity of light. Actually, it is not the velocity of light. It is, you must term it as the speed of light. But generally, we are saying that it is velocity of light. It is a vector? It is also having both magnitude and direction. But it is not a vector quantity. Yes, it is also a scalar. Even though it is having both magnitude and direction, electric current is not a vector. Speed of light or velocity of light, it is also not a vector quantity. That's why, what is the correct definition for the vector? A physical quantity having both magnitude, direction, and also obey laws of vector addition and also obey laws of vector addition. What is meant by this laws of vector addition? We will discuss about this laws of vector addition in the next chapter. That is in the next chapter. Up to that, you must remember that vector is nothing but a physical quantity having both magnitude and direction and also obey laws of vector addition. Even though the physical quantity having magnitude and direction, it is not a vector quantity. Remember that. This is the correct definition for the vector quantity. Okay, for our convenience, the physical quantities are divided into two types. They are scalars and vectors. For our convenience, to develop the physics, we are consider these physical quantities are of two types. Some of them are scalars, some of them are vectors. You must remember the definition for both of them. Next. I will enter the concept. It is a motion in a straight line. Actual concept, it is a motion in a straight line. Where deviate from that motion in a straight line, we are observed that some basic quantities which are present in the physics, that is physical quantity, fundamental quantity, derived quantity, scalar, vector. Now, what is meant by the motion in a straight line? A particle. Do you know about the particle and object? Just we are discussed that. Okay, particle or an object, anything you can consider. A particle moving along the same straight line without changing its direction. If the particle is moving along the same straight line, then we can say that that particle having the motion in a straight line. That particle is having the motion in a straight line. And I am saying that here the particle is moving along the x-axis. I think you know about the Cartesian coordinate system in your mathematics. Cartesian coordinate system. X, Y, Z axis, origin, all these things. Now I want to consider a particle is moving along the x-axis, positive x-axis. Okay, what type of the motion does it exhibits? Motion in a straight line. Now, this type of motion we are also called as rectilinear motion. This type of motion we are also called it as rectilinear motion. Linear motion. Because the particle is moving along the same straight line. That is either along x-axis or along the y-axis or along the z-axis. We are called it as rectilinear motion or one-dimensional motion. Because particle is moving along only a straight line, along only one axis. Either it is x-axis or it is y-axis or it is z-axis. That's why we are called it as rectilinear motion or one-dimensional motion. One-dimensional motion. Okay, motion in a straight line, nothing but rectilinear motion or one-dimensional motion. Remember that. Okay, in this chapter, we will discuss now the definitions about path length and displacement. Path length and displacement. What is meant by path length? Okay, actual length. First I want to give the definition and after that I will give the examples for both of them. Path length. The actual length of the path traveled by a particle. Particle or object. The actual length of the path. The actual length of the path traveled by a particle. The actual length of the path traveled by a particle we are called as path length. Actual length of the path traveled by a particle. I am not saying distance here. Remember that. I am not wanted to term it as the distance. Here in +1 course, we will call it as path length. It is the actual length of the path traveled by a particle is called path length. Displacement. Okay, what is the definition for the displacement? Tell me. In our ninth standard, what is the definition? Yes, the shortest path length or the shortest distance. You are saying it as in that manner. Now, in case of the distance, I want to call it as path length. The shortest path length traveled by the particle is called displacement. Okay, I will write it in this manner. The shortest path length traveled by the particle. Path length traveled by a particle. The shortest path length traveled by a particle we are called as displacement. Okay. Whether instead of this definition, I want to give another manner. The definition in the another manner. Why I will give the definition in another manner, I will explain little later. Or the difference between final position and initial position. The difference between final position and initial position of a particle we are called as displacement. The difference between final position and initial position of a path traveled by the particle. I am sorry. The difference between final position and initial position of a path traveled by the particle. The difference between final and initial positions of a path traveled by the particle we are called as displacement. Now you tell me, does these two are the fundamental quantities or the derived quantities? These two are the fundamental quantities or the derived quantities? Yes. These two are derived quantities because it is derived from length. It is also derived from length. That's why these two are the derived physical quantities. Yes. Okay. What are the SI units of path length and SI units of displacement? SI unit. For it, SI unit is in System International. What is the unit for the path length? Actually, it is derived from a fundamental physical quantity, length. Therefore, for path length, SI unit is meters. Simply you can use small m. Don't say it is empty. We should not use in this manner. Okay, 10 meters. Enough. Don't say it is ms or mts. These two are wrong representations. 10 m. It is the correct representation. Remember that. And what is the SI unit of displacement? It is also derived from the physical quantity length, fundamental physical quantity length. Therefore, SI unit is meter. You can use in this manner. Don't use plural after the symbol of unit. Any unit you can consider. After the symbol of the unit, you should not use the plural. Okay, if you want to write it in full form, you can use 10 meters, 10 seconds, enough. 10s. It is also actually wrong representation. SEC. No, it is the correct representation. Remember that. Generally we are using in this manner, but this representation is wrong. It is the correct representation. Okay, 10 seconds. Okay, 10 kilograms. And 10 small k, small g. Don't use it as the capital letter. Small k, small g. Don't use 10 kgs. It is the wrong representation. Remember that. Otherwise, you can write in this manner 10 kilograms. After the symbol, you cannot use the plural. Remember that. Okay, what type of the physical quantities these two? Derived physical quantities. In these two, here, for our convenience, we can say the path length is a scalar quantity. It is a scalar quantity. Path length is a scalar quantity. And displacement is a vector quantity. What is meant by the scalar? It is having only magnitude. It is not, okay, here it does not require to specify its direction. That's why path length is a scalar quantity. Displacement, it is a vector quantity. What is meant by the vector? It is a physical quantity which is having both magnitude, direction, and also obey laws of vector addition. Laws of vector addition. Remember that. Okay. Okay, I will explain the examples to for these path length and the displacement in the next class. Okay, thank you.